Good everyone, my name is Graphics. Now if you look at the front of a screen, there's a problem that is displayed in front of the screen on fluid mechanics under hydraulics and hydrology. And the question goes like this. It says, an undiluted coagulant has an absolute viscosity of 0.48 kilogram per meter second and a specific gravity of 1.15. The fluid is to be pumped at a rate of 3.78 liter per meter per minute through 15.25 meter pipe with 15.8 millimeter internal diameter. What is the head loss due to friction? Now, like I always say, for you to know the direction to go, you need to write out your data, which is your parameter, or we'll say the givens. Now, solution. The data that we have in this associated with this question, the first one here is the absolute viscosity, which is given by this symbol, is equals to 0.48 kilogram per meter second. The next one, it says that the specific gravity of 1.15. So we say S dot G is equals to 1.15. Now the next one, it says the fluid is pumped at a rate of 3.78 liter per minute. Since it is at a rate, it is related to time. So that is the discharge. So the discharge is given as Q equals to 3.78 liter per minute. Now the third one given here, it says the diameter, the length of the pipe. Since through 15.25 pipe means the length of the pipe is 15.25 meter. Now the next one here given is the diameter, the internal diameter of the pipe, which is given as 15.8 millimeter. Now we're told to look for what? The head loss due to friction. We call it H subscript F. Right? Now recall the head loss HF is given as 32 times viscosity times velocity times length all over the density times gravity times diameter square. We'll say equation 1. So that's for that given expression. Now if you look at the formula that I just wrote down, you discover that we have the viscosity, we have the length, but we don't have two parameters, which is the density and the velocity. So the first thing we have to do is to first of all calculate for velocity. Now, calculating for velocity. Now recall, we know that this charge Q is giving us the area times the velocity. Now from the parameter, we can rewrite this by saying that the discharge Q is equals to what is the area? Area is pi d square over 4 times the velocity. Now from the parameter, the discharge is giving us, if you go back to the parameter here, Q is in liter per minute, and we know discharge is measured in what? Meter cube per seconds. So you need to convert that liter per minute into meter cube per seconds. So we are going to say that 3.78 liter per minute, that is over minute, is giving us 3.78. 1 liter is giving us 10 power minus 3 meter cube. So all over 1 minute is giving us what? 60 seconds. So over 60 seconds. Now if you bring the 10 power minus 3 down, we'll be having 3.78 divided by 60 times 10 to the power of what? 3. Now this will now be giving us 3.78 divided by Now 60 times 10 to the power of 3 is 1000. So 60 times 1000 is 60,000. Now if you divide 3.78 by 60,000, you'll be having what? 0.000063 meter cube per second. Now that is what we are going to input here. So our teacher is giving us what? 0.000063 equals to pi means 22 over 7, and 22 over 7 can be written as 3.143 times the diameter square. The diameter from the parameter given as what? If you convert millimeter into meter, that means you divide by 1000 and you'll be having 0.0158 meter. So if I put it, we'll have 0.0158 square, right, divided by 4 times the velocity. Now you can rewrite this by saying that 0.000063 equals to 3.143 times 0.0158 square is going to give us 0.00785 divided by 4 times the velocity. Now if you divide it by 4, you'll be having 0.00063 is equals to 0.00196 times the velocity, 196v. Now if you divide both sides, what is common? What do you want? You want v to stand alone. So you divide both sides by the quotient of the v, which is velocity. And the quotient of the v velocity is what? 0.000196. So you divide both sides by it. And when you do that, discover that at the right hand side, the 0.000196 will equate to 0.000196. So you're left with v in the right hand side. Now when you divide 0.000063 divided by 0.000196 at the left hand side, you'll be having v equals to what? 0.321 meter per seconds. So that is our velocity. Now the other one that I said we don't have is the density. Now calculating for density. Recall, we know from our basics in fluid mechanics that the specific gravity S dot G is equal to what? The density of a liquid over the standard density of what? Of water. And from our parameters, the density of the specific gravity of the liquid is 1.15 equals to the density of the liquid. What liquid are we talking about? The undiluted coagulant. All over what? The density of water, which is 1000. Now if I can multiply, I'll be left with density of the liquid, which is the undiluted coagulant, is equals to 1.15 times 1000. Now the density of the liquid will now be giving us 1150 kilogram per meter cube when you multiply both of them. So we've gotten everything we need for the expression in equation 1, right? So substituting all that as into equation 1, we'll have that the head loss due to friction HF is equals to the 32 multiplied by the viscosity, which is 0.48, multiplied by 0.321, which is the velocity, times the length, which is 15.25, all divided by the density, which is just calculated, which is 1150, times the gravity giving us 9.81, that is acceleration due to gravity, times the diameter square, which is 0.0158 square. So in multiplying it, we'll now have that my head loss due to friction HF is equals to 75.19. When you multiply all the numerator, you have 75.19 divided by the equation of all the denominator, which will give us 2.8163. So when you divide both of them, you now discover that the head loss due to friction is equals to 26.69 meters. So if you found this video helpful, Please don't forget to like and also don't forget to click on the subscribe button. Thanks for watching.